Day 22, Monkey Market. As you're all teleported deep into the jungle, a monkey steals the historian's device. You'll need to get it back while the historians are looking for the chief. The monkey that stole the device seems willing to trade it, but only in exchange for an absurd number of bananas. Your only option is to buy bananas on the Monkey Exchange Market, the MEM. You aren't sure how the exchange market works, but one of the historians senses trouble and comes over to your help. Apparently, they've been studying these monkeys for a while and have deciphered their secrets. Ooh, the monkeys have secrets. Today, the market is full of monkeys buying good hiding spots. Fortunately, because of the time you recently spent in this jungle, you know a lot of good hiding spots you can sell. If you sell enough hiding spots, you should be able to get enough bananas to buy the device back. Oh, that's cute. On the market, the buyers seem to use random prices, but their prices are actually pseudo-random. Thank God. If you know the secret to how they pick their prices, you can wait for the perfect time to sell. The part about secrets is literal, the historian explains. Each buyer produces a pseudo-random sequence of secret numbers where each secret is derived from the previous. Okay. I've done some like pseudo-random number generation logic before, so I'm familiar with this. Thank God. So I'm guessing they each have like their own unique seed, but how about I stop assuming and I'll read ahead. In particular, each buyer's secret number evolves into the next secret number in the sequence via the following process. Okay, so we have an evolution step to go from one to the next. Calculate the result of multiplying the secret number by 64. Then mix this result into the secret number. Finally, prune the secret number. Okay, so we have to mix and we have to prune. I have no idea what those means, but I'm assuming we'll find out later. Calculate the result of dividing the secret number. Okay, so we multiply by 64, then we divide by 32. I hate to jump ahead, but like multiply by 64, I think you mean shift 6. And then divide by 32, I think you mean shift 5 in the other direction. Are they all going to be exponents of 2? Or, well, let's find out. Round the result down to the nearest integer. Okay, that's easy. That happens automatically. Then mix this result into the secret number. Finally, prune the secret number. So we always mix and we always prune. Calculate the result of multiplying the secret number by 2048. Okay, that's 2 to the 10. So we have 2 to the 6, 2 to the 5, and 2 to the 10. Then mix this result into the secret number. Finally, prune the secret number. Okay, so we always mix and we always prune. Each step of the above process involves mixing and pruning. Got it. To mix a value into the secret number, calculate the XOR of the given value and the secret number. Oh, that's easy. Okay. Then the secret becomes the result of the operation. If the secret number is 42 and you were to mix 15 of the secret number would become 37. Okay, so the secret number gets overridden as part of the mixing thing. We mix the number into the secret becomes the new thing. Got it. To prune the secret number, calculate the value of the secret number modulo 16 million. So that's 2 to the 24, right? That is 2 to the 24. Because that's 16 million and when you store RGB colors, 8 bits of red, 8 bits of green, 8 bits of blue, that gives you 16 million possibilities. So that's 2 to the 24. I can double check that, but I'm pretty sure this number is 2 to the 24. Then the secret number becomes a result of that operation. If the secret number is whatever, and you were to prune the secret number would become this. Okay, so what this actually means is keep the first 24 bits of the number. That's actually all it means. Throw out bits 25 and above, just keep the first 24 bits. So we don't get excessively high. Okay, I'm following this. So how does Bash handle bit math? Fine. Handles it absolutely fine. If you use double parens for mathematic expression, we can raise something to a power with star. We can do left shift. We can do right shift. We can modulo. We can do all sorts of things like that. So it's pretty powerful. It's not the fastest, but it's pretty powerful. After the process completes, the buyer is left with the exact secret number in the sequence. The buyer can repeat this process as many times as necessary to produce more secret numbers. So if a buyer had the secret number 1, 2, 3, the buyer's next 10 secret numbers would be... Okay, I'd have to write code to verify these. Each buyer uses their own secret number when choosing their price, so it's important to be able to predict the sequence of secret numbers for each buyer. Fortunately, the historian's research has uncovered the initial secret number of each buyer. Cool, so we know their seed number. 1, 10, 110, 20, 24. Cool. This is the initial number of 4 different hiding spot buyers in the Monkey Exchange Market. If you can simulate secret numbers from each buyer, you'll be able to predict all their future prices. In a single day, buyers each have to generate 2,000 new secret numbers. In this example, for each buyer, their initial secret number and the 2,000th new secret number they would generate are this. Okay, cool. And the puzzle input is just a new line separated list of numbers. Oh, that's so easy. Adding up the 2000th new secret number for each buyer produces this. What is the sum? Oh, okay. So generate this, add them all together, take the sum, and that's what we're looking for. Okay. This seems fine. I'm going to make some predictions here. We have to get the 2000th spot. Running this 2000 times is probably fine. Running this 20 trillion times is probably not fine. And I'm guessing that's what we're going to have to do. I could be totally wrong, but if we do have to do that, we'll have to investigate this process of shifting the numbers over, mixing them back in, shifting them back, mixing them back in, shifting them really far, mixing them back in, and then pruning off. Like, we'll have to look at that mathematical formula. This is like, we're using XOR, so like we're like checksumming the data in a way. It's almost like we're using 24 bits to store like a small RAID 5 configuration of disks or something like that. I'm jumping ahead, and I'm just throwing out all the technology I have, so that's where my biases are. So let's go ahead and actually get started on this. Where are we? We are in day 21. Nope. Day 22. There we go. Vim example input dot text. Nice thing is the example input, I'm just going to write it. That's the example input. Super easy. And if I had to guess, the real input is probably not going to be that crazy. Never mind. The real input is that crazy. All right, unsharing. Pasting in the real input into my terminal right now. Let's make sure I pasted it correctly. Okay. Closing that out. Reshare. And let's get an idea. Okay, so the example input has 4 numbers. The real input has 1,700 numbers. So, okay, yeah, we got, slightly different, but we're dealing with an absurd number of bananas, so let's go. Okay, let's make part 1. We need to read that file in, so we'll just do read array-t inputs for input in. There's really no reason to read them all in. We could just do it in a line, but who cares? For input in inputs, done. You could parallelize this since every buyer is independent of every other buyer. Oh, you absolutely could. You could absolutely parallelize this, but I'm not even going to think about that. But yeah, that's pretty much the first thing I go for, is looking at the inputs and thinking, do they rely on the inputs around them? If yes, parallelization can be difficult. It's not impossible, but we just have to put more work. But if they don't rely, if they're independent, it's parallelize all day, man. Fork and exec. That's what we got working for us. Cool. Part 1, read in from example, and it should just print the example input. Cool. Yeah, I would just need to manage the children. Exactly, because I don't want to, here's the thing. I'm going to be totally honest. If I forked off 1,700 bash processes, my computer would be fine. Like, it's actually just the truth. I would just rely on the Mac OS scheduler to handle it for me. It would really be fine, but I would still like to limit it myself. So I would limit it to like a max 50, or maybe Bad Cop will join and teach me how to use GNU Parallel finally. So let's see. Now we have to we have to make a function to take a number and generate next number. So what would that function look like? We could make an evolve function. So I've been doing this new thing where I make small scripts that we can just test in isolation. So I think that's what I'm going to do here. I'm going to make an evolve function. And this script is just going to have a function in it, so I can source this in. And then if we run it interactively, this is such a cool trick. I love the if return. So we can run this on the command line, and we can just evolve a single number. So local num equals $1. Now we will go through and run this whole function on it. Like I said, this is probably going to not work for part 2, but I don't care. So in order to do this, we need to calculate the results of, oh, you know what? Here's what I'm going to do. Here's what I'm going to do. Ready? Incoming. There we go. Matthew or Matt. Wait, did we determine, is it Matt or Matthew? What do you prefer? I think you said you didn't care, if I remember correctly, but I want to make sure I'm being respectful. Because you might be interested in what's going on here from a Vim point of view, where I have this single long line down here, and I want to comment it, so I just put the comment in front of it. I'm in navigation mode. I press greater than to move it over to the right, and then I press GQQ, which will break them into 80 lines and automatically put the comment character at the beginning. So now these are broken into multiple lines, and I have my max my max width set to 80, because that's what I like. I like 80 columns. So that's kind of a fun way I can take stuff and put them into my code without it being too gnarly. So now I can just implement these one by one. Thanks for Coproc, learn something new. Yeah, I should make a video on Coproc. Well, first I have to learn Coproc, then I can make a video on it. Maybe I can learn it on stream and then just do that. Oh yeah, no problem, man. All right, so calculate the results of multiplying the secret number by 64. Results equals secret. The result equals the secret times 64. Then mix this result into the secret number, finally prune the secret number. So we mix it together by saying secret XOR equal result, secret modulo equal it's 1677216. What is that? It's 2 to the 24, I think. Let's just use the big number. But all we're basically doing is we're just chopping off anything above that. So this is our prune, and this is our mix and our prune. So calculate the result of dividing the secret number by 32. Cool. Calculate the result by, oh, we don't need to put local here. Let's do calculate the result of multiplying the secret number by 2048. Yeah, these are all just like little shifts and stuff. Okay. After this process completes, the buyer is left with the next secret number in the sequence. The buyer can repeat this process as many times as necessary. Okay, so secret is it. You are right. It's A shifted to 24. Yeah, that's what I thought. Because like I know this number. Like, I remember this was a big deal back in the day when you would get a display and it would say we have 24 million colors or 16 million colors. Like, yeah, 24-bit color depth. Like that's what you're talking about. Shout out to your Bash 2048. Yeah, dude, that's literally what I was thinking about when I saw 2048. That's really funny. All right. Somiyako secret. So that's it. Now we have an evolve function. So if we evolve, here, I'll show the steps actually. So according to this, if the buyer had the secret number 1, 2, 3, the buyer's next numbers would be these. So I'm going to save this in a file. I know you can't see what I'm typing, don't worry. All right, cool. I saved them all. I'll show you what I did. I made a file called sample.txt. And this shows the evolution step of a number. So if I were to evolve 1, 2, 3, we should get 158879550. Looks good to me. If we were to evolve this, we would get syntax error because I copied it incorrectly. 16495136. Okay, yeah, that's fine. We're kind of done. We're basically done. So now we have an evolve function. All right, so let's pull that in. Not shift, I mean A and, yeah, whatever. That. Let's pull in the evolve function. And then what we can do is for inputs, we can echo the input, and then we have to evolve it 2,000 times. So for I equals, or no, you know what we can do? I in 0, 2,000. This might actually include 2,000, so I might go one further, but we'll deal with that when we get to it. Input equals evolve input, and then we can echo input. I'm just going to call it secret because it makes it very clear what we're doing. Cool. Now this should work. I don't know how long this will take to run. Well, that's also not... Well, it might be right. No, it's not right. Why would I say that? Yo, what's up, the Rational Bird? How you doing? Is that for syntax going to create a 2000 element list of values or just incrementing a counter? It's going to expand this into 2000 different things that for will have to loop over. So yes, this will become 2000 unique things. However, this is not unoptimal when it comes to bash itself because for is built into the bash language, so it's aware of this. It's not forking an external command with this many arguments. So bash has a way of dealing with this. I'd have to look in the source code to verify that, but I've never had issues with any sort of slowness from that. But yeah, this will expand it to 2,000 different things. It might even expand it to 2001 different things. So that could be a problem. Yeah, that line was the problem. Okay. One should be 8685429. Okay, so yeah, I think we're just wrong here. You know what? For the sake of consistency, I equals 0. I less than 2000. I plus plus. Let's just be verbose. This should be 8685429. Cool. 4700978. Nice. 15273692. Nice. 8667524. Awesome. That's, I mean, it's not the fastest thing in the world. Let's make this faster, just because I know it'll take a little bit for the first one to run. For evolve, we can give it a n times thing to do. A second argument of how many times we want to evolve it. And then we can do this. For I equals 0, I less than n, I plus plus. That's what we'll do. So we'll just do it in here so we don't have to keep, you know, creating the subshell to run it. There we go. So now this will take a number. So now in our part 1, we don't have to actually create the loop. We can just give it the number. We could say evolve secret 2000 and then just echo the secret. So this should be faster. Significantly faster. Yep. Do curly braces include edges? If so, they did an extra iteration. I believe so. Yeah, I think that's what was happening there. Because that's what I was thinking. Because like, if I did 0 to 1, it resulted in 2 things being printed, so it would iterate 2 times. When in my brain, this should only go like, you know, once. So yeah, I think that's exactly what was happening. Who can make a poll if Dave is going to rewrite this in Rust at some point today? I don't think I'll be doing that. I don't know if anyone here can make a poll. I mean, I can. All right, that looks good. So now I need to just add the logic to what do they do? They add them all up. Yeah. Have n evolutions as $1. I have it as $2. Or you're telling me that would be better to do it that way. Accum equals 0. Accum plus equal secret. Echo total equals accum. This is it, right? Total is 3732763, and I should have gotten 3732763. Hey, we're right. Awesome. Ready? Let's get the real answer. We have to do this, what, 1,700 times? It's not that many times considering. And also, this is absolutely something that could be parallelized. So that is something to keep in mind. We could make this a lot faster. I meant as an argument to the script that gets passed to the evolved function. Oh, yeah, you're right. You're right. Drum roll, please. Exactly. I have no idea how far we are, so I might just be committed to doing this. I'm not committed. I'm done. Cool. I should have put like a little... I always do this. I always run the example input in like half a second, and then I think to myself, oh, I should have added a progress bar for the real input. But sometimes you don't know where the progress bar makes sense until you start doing the slow action. So, yeah. Even just printing like the position that I was in right now, the value of I or something like that, it'd be nice to see. Hey, we got it. Here we go. You all ready? This should be the answer. Let's go. Let's go. Nailed it. Nailed it. So easy. Oh my God. Streaming for less than an hour. We nailed part 1. Super easy. Super straightforward. That's the right answer. We found the historian. Oh man. What's up, J7 Hunter? Welcome. Yeah. Dude, nailed it. Awesome. I'm frightened. When part 1 is easy, that usually means that part 2 can be a doozy. A doozy. Speaking about progress bars, PV might be a good topic for the YSEP series. I totally should. I also, oh man, here's a nit. I use PV in one of my backup scripts to limit the upload that I do to my offsite backup so it doesn't crush my upload. It does it like I limit the amount of upload. I use PV to limit the upload. PV, Pipe Viewer, has the ability to modify the stream. I hate that it's named that. I understand that it's fine and programs can do more than what their name is, but I hate that Viewer can modify something. It's just a small nit. Just a small nit. But I actually do love that tool. Congrats. Awesome. Awesome. Yo, thank you, everyone. Thank you. Thank you. We're crushing it. We're killing it. We're moving along. Let's go. Continue to part 2. Also, if you're watching on YouTube and you like what you see, go ahead and hit that subscribe button. I like seeing that number go up. If you're watching on Twitch, go ahead and hit that follow button. And if you haven't had Twitch Prime, go ahead and give me your free money. I want your money. It's not going to a charity. It's going to me. I'm greedy. Pay me. How was that? Was that good? Let's see. But only your Twitch Primes. I don't want you guys to pay real money. I want you guys to use the money that you've already paid to just go ahead and give me some of that sweet Amazon bucks. Awesome. Let's jump into it. Part 2. Of course, the secret numbers aren't the prices each buyer is offering. That would be ridiculous. Instead, the prices the buyer offers are just the ones digit of each of their secret numbers. Just the ones digit of each of their secret numbers. Okay, so if a buyer starts with secret number 1, 2, 3, that buyer's first 10 prices would be, yeah, just the last digit. Fine. Yeah, sure. Got it. Modulo 10. The price is the number of bananas that buyer's offering in exchange for your information about a new hiding spot. However, you still don't speak monkey, so you can't negotiate with the buyers directly. The historian speaks a little, but not enough to negotiate. Instead, he can ask another monkey to negotiate on your behalf. Cool. Awesome. Sweet. Unfortunately, the monkey only knows how to decide when to sell by looking at the changes in price. Specifically, the monkey will look... Oh, this is really confusing. The monkey will only look for a specific sequence of 4 consecutive changes of price, then immediately sell when it sees the sequence. This is so interesting. Okay. So if a buyer starts with the secret number 1, 2, 3, that buyer's first 10 secret numbers, prices, and the associated changes would be... Okay, so the price went from 3 to 0, which was a negative 3. 0 to 6, which is a positive 6. Went to 5, which is negative 1. Okay. Cool. Cool. Note that the first price has no associated change because there was no previous price to compare it with. Got it. In this short example, within just these first few prices, the highest price will be 6. So it would be nice to give the monkey instructions that would make it sell at that time. It would be nice. The first 6 occurs after only 2 changes. So there's no way to instruct the monkey to sell then, but the second 6 occurs after the change -1, -1, 0, 2. Gotcha. So if you give the monkey that sequence of changes, it would wait until the first time it sees that sequence, then immediately sell your hiding spot information at the current price, winning you 6 bananas. Is it possible to see this sequence and get something other than 6? Each buyer only wants to buy 1 hiding spot, so after the hiding spot is sold, the monkey will move on to the next buyer. If the monkey never hears that sequence of price changes from a buyer, the monkey will never sell and will instead just move on to the next buyer. Worse, you can only give the monkey a single sequence of 4 price changes to look for. You can't change the sequence between buyers. This is so confusing. Okay. You're going to need as many bananas as possible, so you'll need to determine which sequence of 4 price changes will cause the monkey to get the most bananas overall. Each buyer... Oh my god. Each buyer is going to generate 2,000 secret numbers after their initial secret number. So for each buyer, you'll have 2,000 price changes in which your sequence can occur. Okay. Whew. I'll have to think about this. There's a lot going on here. Suppose the initial secret number of each buyer is 1, 2, 3, 2024. Okay, we're different this time. There are many sequences of 4 price changes you could tell the monkey, but for these 4 buyers, the sequence that will get you the most bananas is -2, 1, -1, 3. Using that sequence, the monkey will make the following sales. For the buyer with an initial secretive number of 1, changes blah, 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 first occur when the price is 7. Price is 7. This one does not occur in the first 2,000. And this one is 9. So by asking the monkey to sell the first time each buyer's price goes down by 2, up by 1, down by 1, up by 3, you would get 23. What the heck, dude? Figure out the best sequence to tell the monkey so that by looking for that same sequence of changes in every buyer's future price, you can get the most bananas in total. What is the most bananas you can get? Dude, I'm following this, but I don't even know how to approach this problem. So we're going to have to break it down in order to understand this. So it generates a random number, and if we take the ones digit or modulo it by 10, take the remainder, we get this number. This is just literally like this 0 is just here. This 6 is this 6. That's the price. And the price it was before and the price it was now, that difference is the action, the price action, which is just literally the difference between the last one and this one. The price is the number of bananas. So we want that to be highest. We want to see what sequence led to it being highest. Yo, what's up, Turkey? How you doing, man? Yo, thank you for the bits, dude. That's awesome. Heck yeah. Love it. For each sequence of changes, calculate how many bananas you can get from all monkeys, maximize yield. Exactly. That's what we're doing. Unfortunately, the monkey only knows how to decide when to sell by looking at the change in price. So what we have to tell the person we have to tell our broker that, hey, when you see the sequence, -3, 6, -1, -1, you should sell. You should sell right at that moment. But it will look for that sequence in all of the inputs. So we need to make sure that this sequence maximizes our yield. There's a couple ways we could approach this. So you guys know me. I'm going to explain the brute force solution first. For every single number, we make a cache. We make a file of new line separated numbers that will yield from that. So for each number, like let's say, for input, let's just do some example input here. For the number 1, the number 1, we'll have a file called 1. Oh, you can't see what I'm doing. So here's our example input. We could make a file called 1, and in here we could have 2,000 lines of evolutions, and we could cache all of them, and then we could go through and get all the price actions and the bananas that yield those price actions. That's the brute force way of doing it. That sucks. I don't think I'm going to do it that way. We might. So it's solvable that way. The other way to do it is to come up with every possible combination of price action patterns. But I think we're looking at a very, very large number. Like, tell it to try looking for price action, 1 + 1 + 1 + 1 or something like that. Then tell it look for 1 + 1 + 1 + 2. We're looking at like 10,000 possibilities there, which might not be the end of the world, but that does kind of suck. So the question is, can we derive any sort of pattern that's meaningful from this? Dude, this is actually wild. Here's my hunch. I'll tell you guys my thought process here. My hunch is this way of creating the secret numbers is breakable. This is my hunch. It's breakable, and we can come up with some sort of pattern from it where we could figure out how a number will change And there's going to be only a strict set of them. I mean, technically, there's only going to be 2 to the 24th. There's going to be 16 million possibilities, so we always limit it to that. So that's my hunch. And because if we look at what we're doing here, multiply the number by 64, we actually just shifted it over 6. We shifted it over 6. So all we did was like take an original number, move it over here, mix it back in, move it all the way past the direction, mix it back in, and then move it way out here, mix it back in. Like we're doing something that we could break this somehow. I could write code. CP evolve to, let's move evolve to evolve. I know you can't see what I'm doing. We're going to move evolve to evolve part 1. That way we just don't like lose it. This part 1 solution just works. Let's CP evolve part 1 to evolve part 2, and we'll come up with a new evolve function for part 2. And what we can do here, we can just echo it a bunch of times. So let's evolve part 2, the number 1, 2,000 times. This will result in 2,000 numbers being printed. We could cache this. So hear me out. We could cache this to 1.text, right? Now we have 1.text. We have the first 2,000 evolutions of 1.text. And we could write a post processor to grab the last digit and calculate the price action and create a file that is number space price action. We could do that. I don't know how we then process those files to get anything meaningful out of them. I'm not saying it can't be done. I just don't know how we would do that. Because remember, some of these aren't going to have valid solutions. Add module equal 10. You could do that. Just for printing it, you could totally just do that. Because the number doesn't really matter. I like having all the information in there, but let's just think about this. Yeah, because we have the secret here. If we can get the price, so let's say the price is the last digit of the secret. Equals secret modulo 10. And then we could echo the secret and the price. So let's go ahead and see what this looks like. Cool. So now we have the secret number and we have the price. Since it's only one number, wouldn't you only have 10 patterns? No. Because the thing that we have to tell our broker is 4 different things. So it's going to be 10 times 10 times 10 times 10. Now, it's not that, I mean, looking through 10,000 patterns probably wouldn't be the end of the world, actually. Why the braces around the price declaration? I still feel kind of new to Bash, to be honest. I don't even know where I did that. Where did I do that? The brackets around the price declaration. Here is where I declared price up here, where I just made it local. And then here is where I actually set it for the first time, so I initialize it here. These parentheses, these double parentheses in Bash, tell it that we're doing math or arithmetic expression. So you can do like, I think you can do help parenthesis in Bash. Yeah, and you'll learn about arithmetic expression. You can learn more on the Bash man page. I think let is also a similar thing. Let is equivalent to open and close parens, but open and close parens is preferred for a couple reasons. Let will give you a whole list of all the mathematical expressions you can do in Bash, which is super useful. Like super, absolutely useful. Let me think about this. So we have the price. Now we need the action. In order to do the action, we need the last. So we can do action equals empty string. If dash n last, then the action is last minus price. I might have that backwards, but who cares? And then I think, let me pull up the website real quick. Yeah, the initial sequence. Okay. So for part 2, they actually give you a different set of example inputs, and we're going to use that. Vim example part 2 dot text. There we go. So we can mess with those. But we should have, it should be 19 raised 4 equals blah, 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 unique sequences, I believe. It's the differences, so we also have to take into account the negative numbers. Hey, you're right. You're right. You're absolutely right. That is true. So it's even more than I originally thought of. I said it was 10,000, and that'd be great if there were 10 possible numbers, 10 raised 4, but there's 19 possible numbers, 0 through 9 in the positive, and 1 through 9 in the negative, because zero's, was it 2's complement or whatever? Zero's not going to be negative. So yeah, so that gives us 130,000 things to try. So significantly bigger, not necessarily undoable, but probably undoable. But yeah, that's a really good point. So if we evolve 1, I don't know, 5 times, we don't have any action at all. Oh, because I'm not setting it. We have to set last equal to price. Okay, now to go from 3 to 3, we did 0. To go from 3 to 9, we did -6. Okay, we have this backwards. To go from 9 to 5, we added 4. Yeah, that's incorrect. That's what I thought. I thought I had it backwards. It's actually price minus last. Cool. This all looks right. So here's the secret number. Here's the ones digit of it. And then here's the change from the last number above it. So from 3 to 3, it's a 0 change. From 9 to 3, it's a change of 6 in the positive direction. From 9 to 5, it's a change of -4. Cool. Cool. I can see the forks coming out later. Yeah. We'll see. We may have to get more mathy, but until then, let's get an idea of what this would even look like. We can go through and generate every possible solution. So for like 1, 2,000, it's not bad. That doesn't take long to generate all possible things. Now the question is, what yielded the most bananas? We could go through and get a list of I don't think brute force is going to be viable. Here's what I'm thinking. Write all these out to a file. Go through the file, literally check each 4. So like for every single line, we just grab the price action. So if there's 2,000 lines, there's 2,000 minus 4 sequences, like 1996 or something. I don't know if that's correct. 1996 sequences, so we just keep track of every possible sequence, and we go through every possible input to grab every possible sequence, and then we test every possible sequence against every possible input. I think that's going to suck, and it's going to take 8 million years. There's probably a better way to do this, but I'm going to start writing that code because I want to get an idea of how long it takes. So let's go ahead and start caching some of this stuff. So if we evolve part 2, what's our example input? Okay, let's evolve part 2, 1, 2,000 into, CP part 1 to cache all. Well, we're going to call this cache all. Bear with me, it's going to make sense. I'm going to write a program that will cache everything. So we'll pull in the version 2 version of evolve. We'll read the inputs, and then we will print what we're doing to the screen. Processing secret. And then we do evolve that secret 2,000 times into cache secret.text. Okay, so now if we run cache all, with the example input. Now we look at the cache. We have these 4 files. So we can vim cache 10.txt, and there we go. There's all our possible price actions. So, where does this leave us? Let's think about what we can do next. We can grab all the possible actions. So let's try this. Extract actions. I know this is kind of scuffed, but, you know, here we are. Here's what I'm thinking. For file in cache star.txt, do, done. We'll loop through every single file that we've cached. Cool. We will read in that file, and we will make a we'll make a list of patterns. We'll be fine. We'll figure this out. Using the file system external memory. Dude, that's exactly what I'm doing, man. I love it. That sounds like a solution. I'm not reading that. I mean, I know you might be like trying to figure out, but I'm not. It sounds like it could almost be a hint, so I'm not gonna check that out. I'm gonna keep doing what I'm doing. So we have this $F. Also, yeah, if you are new to the stream, please don't give me any hints or spoilers or anything like that. I am trying to figure this out on my own. If you see bugs or something and you want to jump in, or I'm clearly, you know, like fighting something that seems silly and dumb, like bash related, not the puzzle, fine. But if I'm driving down the wrong direction on the road with this puzzle, let me drive, baby. That's the fun of this. So that just an FYI to people just tuning in. So what are we gonna do? Now we have this. We can grab out every single possible change. Will the same changes show up multiple times? Because yes, it could show up multiple times, and we will grab the first one the first time it appears. Let's just get all the actions from one file. How about that? Okay, there's all our price actions. We won't have a valid sequence until the 5th line, because the first line's empty, and then we have to read until we keep going. So what do we want? We want we want a ring buffer. That's what we want. Dash n action or continue. Okay, now action's guaranteed to be set. Buffer plus equal action. Oh, we want to put this. We want to put this at the beginning of it. We want to push this on at the beginning of it. Now that I think about it. No. We want to keep it on the end. And then if we're too big, we want to grab... Yeah, okay. If the length of buffer is greater than 4, then we want to get rid of the last element. Yeah. Yeah, so if the length is greater than 4, then we want to unset it. If the length is equal to 4, then we want to print it. We could separate them by whatever, but we'll just do this. What did we push in there? What happened there? Oh, this needs to be the length. Okay. Doesn't the last key going to grow? I don't know. I don't have it working yet, so. This clearly isn't right. Yeah, we're pushing it on the end, so we need to unset the 0th location, which I think just pops off from the front, right? I thought that worked. Yeah, it seems like it should work. Oh, I can just recreate the array. Yeah, that works. So I just recreated the array there with the first element just removed from it. So here's our list of price actions from one number. And we could keep track of how many bananas we were able to generate at that price action. So I'm going to look at the example they gave us. Yo, what's up, Ox? Dude, how you doing, man? Nice to see you. Welcome. Heck yeah, man. We're chilling, dude. We're programming right now. I am so lost. I'm not lost. I'm actually doing pretty okay. Which is good, because yesterday I streamed for 7 hours to get one of the puzzles done, and it sucked, bro. He's Dave Eddie. What will he do next? Whatever the frick I want, man. Apes gonna be so mad when she sees me programming in Bash. She could be like, "Bam, that's not a real language." Shut up, Ape. Oh man. Oh, we're so close to a solution, aren't we? We just need to cache these. Those are some gnarly file names, but they're valid file names. Listen, I can have a file named this if I wanted to. Hyphens, spaces, numbers, those are all valid in a file name. Yo, Turkey and Ox in the same chat. Let's go. So if we have this, we know what price we get at that action. Now, is the price at that action or is the price one before that action? Let me pull up the puzzle and see. Changes -2, 1, -1, 3 gives it 7. It doesn't even use 1, 2, 3 there. Okay. Let me look at my cache for 1. These are valid files for your base bash explainers. Yo, true, dude. I love using file names you shouldn't use. It's like my favorite thing. All right, so according to this, with the initial secret number of 1, changes -2. I'm looking at, yeah, -2, 1, -2, 1, -1, 3. I'm just searching through the file. I know you can't see it. But I'm going to pull it up when I find it. -2. I'm looking for -2 followed by 1. I could grep. Yeah. It's going across multiple lines. That's the only thing I'm thinking about. What's next? A file name with a new line in it? Yep, that works too if you're careful enough. Listen, man, head over to my YouTube and watch the first ever episode of my series, You Suck at Programming. Or just go pull up the episode list here and check out episode 1. I talk about exactly that. I create a file with that name to show how surprising it can be, but it's technically valid, so you should be prepared for it. -2, 1, -1. -2, 1, -1. No, I keep looking at the wrong one right now. Yeah, no. -2, 1, -1, 3. Whatever. Let's actually just start writing the caches out for this. And then we can look for it. Vim has slash. Yeah, I'm looking through less. That's what I'm doing. I know you couldn't see it, but I had the file piped to less. I think we just print the price. I think this is what the output is supposed to look like, because it's the price at that action difference. So, yeah. So yeah, if we extract the actions from 1, according to that file, it should be -2, 1, -1, 3 should equal 7. Hey, it does. And it shows up twice. But it doesn't matter if it shows up twice. We only care about the first one we've seen. Because if we see the sequence another time, we don't care. We throw it out. Okay. So now for extract actions, we'll have a second cache of moves. So in this cache, make dir action and no. All and moves. Let me think about how I want to cache this. Oh my god, I think we're okay. I think we're good. I think we're gonna be good. I think we're gonna be really good. All and moves, move star.text into all, and then for moves, we will store the initial number, the set of moves, and the value will be the price. Oh my god, I think we're gonna get the answer here. Extract action. So we loop over all of these. We get all of these out. We have the data we're going to write, and the initial number is the name of the file. So the file actually has the file number and the number embedded in it, so we can get that out. We can get that out by taking the F, getting the base name of it, take that same number, chop off the .text, and now we are just left with the number itself. So when we do this, we could say num the move, num space move equals price. So now when we rerun extract, all right, I changed where they were cached to. Cool. So for the number 1, the move 8 minus 8, 4 minus 2 gives you 2 as a price. So now we know the possible moves and the price you can get from them. Okay. Where's my cache all function? Yeah, cache all can still do that. So if I cache all, read in from example part 2, it goes through and writes them all. And then we extract actions from, we don't have to do anything, it just knows how to do it. Those should go in make dir -p cache. Let's call them actions. Let's make a file name, which is the num and the buffer separated by spaces, and echo the price into the f name. There we go. Okay. LSR cache, rmdir cache moves. Let's run extract actions. Okay. Seemed like there were too many. It wrote them all to this location. That's annoying. Oh, right. Because in the file name we should have cache actions that. Oh, this will be annoying to remove. Don't do what I did, kids. Or do what I did and learn how to remove these files without removing any of the ones you care about. Because that'd be a scary thing for some people to do. So now if we run extract actions... Why do we have so many? Alright, let me remove the cache completely. Alright. Now we will cache all. Read in from example part 2. So we only get the files we care about. Nice. Now we will extract actions from that cache. Cool. So now inside cache move or actions, we have so many different things now, which is good. We have every possible move for every possible thing. If not dash f name, then write it out. So we don't want to overwrite a file that's already there. This means that we'll only cache the first sequence that we see and not later sequences. So that's how we are going to handle that situation. So it'll technically be a little bit faster. NVIDIA driver install crashed a lot of systems once because of a space and an RM argument. I believe that. Yeah. It can be totally gnarly if you're not careful. Close. Oh, well, we should probably make the file name here, huh? Okay, there's all our actions. So now we need to figure out all of the possible actions to try for every single number. Okay, we can do this. We can totally do this. Yeah. So now that we have every single number in our cache, for f in cache actions star.text do done. Oh yeah, we're gonna get there. Does the first part of your cache file name matter? Yes, it does. Not for storing, we'll get there. We need to break this file into its constituent parts. And the way we do that is we will say the name equals f, strip off everything up to the first or to the last slash. So now it'll be the name.text. So let's get rid of the .text part. I'll show you guys what this looks like. So now we run this. There's gonna be a lot. There's not gonna be a lot. Oh, did I not? I didn't call him .text, did I? Yeah. There we go. Let's call him .text. Okay. So now if we run part 2, there's gonna be a lot here. But here we have the name of every single file that we have encountered, which has a lot of data embedded in it. We have the number and the moves. So what we're going to do is we're going to first make a list of every possible move. That's what we're going to do. And for every single move, we're going to check where it exists in all of the existing cache data. And we're going to sum up all of that data. That's what we're going to do. So in this one, we can break it apart. No, we're in part 1. Because it's the number space the move. So we can read -r the number space the move from the name. And then we are left with number num equals move. And I'll show you guys what this looks like. There we go. So number 3 has this move. Number 3 has this move. So here's a list of our moves. And we know that they're available for all different things. We should have stored them in directories. It would have been easier. But here we are. So now we can do this. No. I want to store them in directories. Sorry, I'm going to get a little bit more confusing here. So in our cache directory structure, where we have cache and then we have actions, I want to make a directory for the number, and then inside there I'll have every possible move. That's what I want. This is an easy fix too, because it literally just looks like that now. So we just need to make sure that, you know, that exists. Cache, actions, num. That's it. That's the only thing we'll do that's different. It's forking out to make dir-p slow. Yeah. That's the only thing that's slow here. That's not a big deal. We can just do it here. There you go. That's super easy. You stuck with moves. Yesterday was traumatic. What do you mean I stuck with moves? Do I have moves somewhere in here? Nope. Yesterday was traumatic, but it's mostly out of my brain now. I don't even think about it. So in part 2, we can't just loop all the actions. We have to loop star.text. And the name is the move is the first part. It's patterns. Oh, yeah. That's funny. All right, so let's break this. The way we can break this is we can just remove cache actions / from it. And then we can ifs equals / read the number and the move from it. So now if we run part 2, we get nothing. Nice. Cool. So we have the number and the moves associated with it. So we need to loop over every single possible move. And we need to sum them all up. So keep track of every single move we've seen. The way we can do that is really simple. Make an associative array of moves. And then we can just set moves move equal to 1. And then we can just, because that will deduplicate them, and that will just have a list of moves to check for move in moves to echo move. These were all of the moves that we have seen in all of the things that we've processed. There we go. So this is irrespective of whatever number was at the beginning. This is just the moves we've seen. And now for each number that has that file, we can add it. If it doesn't have that file, it's just a 0 because the thing will loop and we're not at a problem. Okay. Loop over every possible move. Calculate every possible move. Sum up all the bananas this move will get us from each number. And this is super easy because we can do something really awesome here. I normally don't write code like this, but I'm going to for this because I think it's going to be fun. Cat cache actions star move dot text. As long as we don't quote that star, we'll be fine. This will cat how much we'll get, because the file's guaranteed to be there at least once, and it will be a new line separated list of things. So we just have to sum them up. I'm just going to see if we can do something like this. I think you can just do like, I don't know, I plus equal $1 and print $I. We can do this all in bash. I just want to see if this actually does what I think it will do. Well, it's slow. I don't know if it's doing exactly what I want, but let's see. Why would we ever cache a 0? Oh, no, the price action could be 0. We could totally... Oh, we could speed this up by not caching a 0. We could totally do that. Yeah. Bad cop, we catch you. Yeah. I'm totally pulling a bad cop here. Hey, let's just output all this stuff separated by new lines to standard out and then pipe it to. What does she do? Like paste plus minus something? I have no idea. I don't know how to use that command. Now we have to sum all these up. Just trying to think of a clever way of doing this. I'm trying to think if there's like a cheeky way of doing it, but I think we can just do this. I really would prefer not to reach for awk if possible, but I feel like let's just do it for now and see if we can get the answer. I plus equal $1 and print $I. So now we have the total. Put some progress bars in here. If total is greater than max, then move, then winner equals move, max equals, sorry, yeah, max equals total, v, echo, winner. We'll get you bananas. Okay. I think this logic is sound. I mean, that doesn't look right. What are we printing? Oh. I have an idea. Without even looking, I have an idea. Hey, here we go. I just had a hunch. Len. That's actually what we want. We never increment I. There we go. You could use a \R. This is fine. Now, this is the example input. So who knows how much the real input's going to have compared to this. So this might not be a feasible solution, but I think this is a workable solution. So we'll see. What am I even supposed to have? -1, -4, 9, and -8 will get you 1 bananas. Well, that's not right. Yeah, workable in infinite time. You got it. We're supposed to have -2, 1, -1, 3, and it gets us 23 bananas. Let me do a little test there then. Because if we look at the cache of the actions for number 1, starting at -2, 1, -1, 3, we get 7 there. Hey! This prints that. Let's try this. What if I print all these? Because this is the best one. 779. Cool. And if we awk I plus equal $1 and print $I. Oh, $I. No, print I. I forget my awk. Oh, I forgot my awk. I just had to write it out. It's not $I, it's just I. Let's see what this gets me. -2, 1, -1, 3. That's correct. We'll get you 23 bananas. That is also correct. Hey, we did it. We did it with the whatever. So let's RM the cache. Let's cache all from the real input. Oh boy, this is gonna be a... Yeah. This is gonna be a lot of stuff that happens here. Alright, so we cached everything. What do we do now? We extract the actions. Okay. A little bit slower. Absolutely a little bit slower. Trying to think. We could probably store in memory if we've written out the file instead of just statting the file. But statting file system metadata operations on my system with a ton of RAM should be fine. Yeah. Did you remove the test cache? Yes, I did. Yes, I did. I rm-rf the entire cache directory. Extract action, so we cached it, we extract the actions. How big are these files? Oh, it's going to take a long time. There's like a massive amount of files. We have to go through and stat every single one. I can only subscribe once. Well, skill issue, bro. I don't know what to tell you, man. Sounds like a you problem. Do I even want to know the file size? Like, really? Do I? What am I going to do with this information? We have 13 gigs of cache data on the file system. Not terrible. Not terrible. Not terrible. I feel like I'm skipping over like a mathematical solution here, but who cares? You know, we got the file system, dude. I think all I do is I run part 2 now, right? Where we echo... Let's see. Reading moves from F. Okay. So now we'll just run part 2. Seems excessive. You know what? Maybe it is. I do like that emote. I think that emote's a little cute. Does part 2 have to read in from anything? What are we waiting for? What is part 2 doing? Are we literally waiting for it to just loop all the directories? Like, is there just that? Is it going through and just getting the directories? Is that what's taking so long here? I know directories with too many files used to be just slow to iterate, even without sorting. I don't know if they fixed that yet, or if it's just inherent in how it works. Yeah. I have to think. Yeah, globbing. I think that's what's happening here. Because we're globbing over all these files, Bash is going to handle the sorting of them. If we were in a different language, we would just call readdir, and it would go in readdir order. Okay, we're going now. ls usually takes a flag for that. I think -U on a Lumos. I don't know what it is on other systems where it'll do readdir order, which is nice. It won't try to sort it beforehand, which is really great for directories with like millions of files in them. I don't think we're going to run into argument limits. And the reason I think that is because where I use these giant list of arguments are with bash built-ins. As long as you're using them with bash built-ins, you don't run into like argmax or something because I'm not fork and execing it. So as long as I stick to bash built-ins, we should avoid that. Okay, cool. We're counting up the numbers. Now, printing all of them is probably making it very slow. I think it's advantageous to remove some of these prints. Yeah. Reading moves from. Oh my god, we actually, wait. We were just reading them? Oh god. We were actually just caching the list of moves, weren't we? Oh boy. Okay. Let me do a little test. Cache actions. Let's just grab a random one. Let's see if we can speed this process up a little bit. How many are here? That's not a ton. Okay. Because this first bit of logic that took a bit was calculating every possible move. We could do that ourselves using file system commands, and then we could just loop over those. But I don't think it was the worst thing in the world. Reading all moves. Echo, done reading all moves. Yeah, I don't think it's the worst thing in the world, but there are ways to speed this up. Yeah, because all this is doing is reading in a list of moves. I could just loop over every single directory and copy this text file, overwrite them in some directory, and then we would just have a list of all moves. And it'd be a significantly smaller list because there'd be a lot of overlap. Problem is, now that we're not printing stuff, we don't actually have any sort of indication of, you know, how far along it is, which is pretty funny. I'm gonna let that run, and I'm gonna think of a different cache solution because I think I have an idea. Make dir moves, ls actions star. Yeah, I mean that's really it. ls-u1. I'm gonna do the thing you're not supposed to do, which is, you know, nope, that's gonna take forever. Parse the output of ls. But I mean, this is how you would do it. I would just loop over everything here. Yeah. Oh, we're already working on stuff. Okay. So we found 40,000 moves. We have to go through 40,000, and we are at 100. So this might not be the fastest thing in the world. This is one of those things where if I rewrote this in Rust, like, we would just cruise through it. Everyone here is so nice. Last dumb newbie question. Any good programming books out there? Thanks for all the advice. Yeah, it depends on so many different things. strace could help to see where we are. I don't have strace on this system. We're on a Mac. We would have dtrace if anything. What do you guys say we erase this? What do you say we erase this? And by that I mean try to implement this in Rust. Rust race, Rust race. Let's make it go fast, blazingly fast. Okay. We'll do a nice little Rust race. How do you guys feel about that? Cargo, no. Rust part 2. Do you remember that we only need first match where we break? Yeah, the first time we see a sequence. I'm not sure what you mean. Cargo, new. Rust part 2. Alright, Rust raced. It's happening. cd rust part 2, cargo build, cargo add anyhow, cargo build, vim source main, use anyhow, results. Cool. Maybe I should spell it right. Cool. So where is the data that we need? It's in here, cache directory. We need actions, if we just grab one of them. So there's all our numbers, and there's all our moves, and there's all our values. Okay. So let's use standard fs. Do you guys remember how readdir works? And I'm going to make it up. I think you can do like for num in fs readdir. Now we want actions. I think this is right. Let's debug print it and see. Does Rust have a REPL? No. It'd be kind of hard to have one with a compiled language like this. Is it read underscore dir? Is it really this? Wow, it is. Okay. How do you get the base name of a file entry? Rust read dir. Don't worry, I know you guys can't see. I'm looking at readdir here. It returns a result of readdir. You loop over it, and it gives you a dir entry. Okay, it gets a result of a dir entry. What can we get here? We have a .path on it, a .metadata, which stats it, a .file type, .file name. Hey, what's that? OS string of it. Ew, how do I get the base name of it? Path? Okay, path gives me a path buff. And then with path buff, is there a base name? How do you get the base name? I can pop off of it. Oh, is there a file name? It's like so abstracted. Oh, a path buff can be treated as a path, and then you can get file name on that. Okay, we're getting somewhere. So I think we can do let path equals entry.path, name equal path.file name. This is a function too, right? Okay. What file? What type is that? Is that an OS string? Oh, cool. Nice. Uh-oh. What do you guys like? Do you guys like the speed programming? I mean, we are in a race, right? This thing's already at 3,000 out of 40,000. Uh-oh. We're already at like 6-7%. Okay, so there are all the files there. There's got to be a cleaner way to do this, but let's try this. Let's get a hash set of all the moves. There's cleaner ways to do file manipulations, but I don't care right now. Okay, so now we shadow entry Now we should have the moves for that one. OS string cannot be formed. Oh, it's still an OS stir. What can I do with an OS stir? I can turn it into a UTF-8, right? Two-string lossy? Oh god, wow, what are these string methods? Is that really right? That is right. That's wild. So this gives me a copy on write stir, and then this will make sure that it's allocated. Probably unnecessary, but here we are. So now we can do moves.insert name, and then we'll keep track of all the moves. So when we get down here, we can say like, we found moves, moves.len. Let's go ahead and not print that. So now this will do the same thing. We're going to be slowed down by our 13 gigs of file system data. I look away for 1 second, we're in Rust. You looked away for 10 minutes, buddy. We are racing our bash solution. The bash solution is still running. The bash solution is 10% of the way there. But we're going to race it. Okay, wow. Yeah, even faster than Rust. We're still slowed down by the file system. We have to stat a bunch of stuff. All our data is there, but that's not the worst thing in the world. While we're here, we should also keep track oh, we could do this so much faster. Yeah, we could do this so much faster. Instead of a hash set. Yeah, instead of a hash set, we use a hash map. And we'll get it. Gonna read the file in. Then we have to parse it as a number. I think this will work. Yeah. What do you do? Do you do this? Yeah, what am I doing here? I'm getting messed up with data types now, but we'll get there. It's gonna be not the most efficient code. Oh yeah, it doesn't live long enough. That's fine, we can just add it to that. Okay. Oh yeah. Okay, so now that we found all the moves, we have to go through and find the one that had the largest number of bananas. So for how do we do this? For move and n in move. I think this works. I think you can just do that. Yep. Final is a reserved word. Okay. I think that's right. I do wish it would print what file name gave an error. I realize the way I'm doing it is what's causing the issue here, but it's not the worst thing. Let's see. Oh wait, can I just do this? Now who knows how fast this Rust one is actually running? Because I didn't put any sort of, debug output in it. So I'm guessing it's just hammering the file system right now with a ton of little stats. Just curious why the anyhow and not just unwrap. I just like using the question mark operator without having to think about it. That's kind of why. I use it when I think about it. Other times I just use like unwrap or whatever. You shadowed I after hashmap get. Is it okay? I don't know. I actually don't know, to be honest. Mac OS activity monitor. Yeah, I could do something like that. See what it's doing. I don't think it would share it if I pull it up for you guys. I'd have to explicitly share this app. But yeah, I'm going to be hammering the disks. The disk reads. Oh yeah, disk reads are just maxed out. Yeah. Yeah, the shadowing of I should be okay. Why am I doing this? When I could just use the path. We already have the path here. Cargo, run, dash Q. No. Dash release. Okay, and what are there 1,400 we have to look into? Might as well rewrite the rest of the logic to have it in memory while it's going. Yeah, you can do it. I think it's going to be significantly faster than the bash solution. Once it gets done with this, I mean, I didn't put any timing on it, but once it gets done with this, all it has to do is look through an internal hash map structure to find the one with the highest values. I don't see that being difficult. Technically speaking, I could reverse the hash map and then sort the keys to get the highest one. It'd probably be even faster than the way I'm doing it. Yeah. This is the first step that the bash solution is already done with. That's correct, but I changed the logic slightly. So even though this is the first step, it's actually a mixture of the first and second step. I put it all into one solution. Because I have like compound data structures that I couldn't really do in bash, I can kind of cheat and change the algorithm ever so slightly. So while we're reading the data, we're also reading the entire file in and getting the data out of it and parsing it. The only downside is we're doing this in reader order. So we can't even like look to see if it's alphabetical or not to see if we're even getting close, unfortunately. So we just, this just has to go until like 1400 things are seen. So who knows when that'll be. All right, 8,000 out of 40,000 in the bash solution. Okay, 20%. I think this Rust solution is going to be significantly faster. Of course, watch me just hit a bug, right? Watch like this get to the end and then just hit a bug. So that could suck. Or that could suck. Yeah, so I guess now we're just waiting on both solutions. Now here's the thing. I think this will work and we'll get an answer, but there probably had to have been a more elegant solution, right? Like, there had to have been a more elegant solution for this. Could you cache the hash map in some way in Rust? I mean, it's going to be in Rust memory. I could serialize it out to like a JSON file and read it back in. It'd be significantly faster than pulling it from individual files in the file system. Yeah, I could do things like that. But like, there has to be a better mathematical solution to this. You don't think your solution took that long? Well, you probably didn't cache things out to memory though. Or to disk, sorry. Because I could just cache the whole thing in memory, and if I did it that way, I mean, it'd be significantly faster. You say it's stepping through at the same speed, and I know what you mean because it's only the first step, but like, once this is done, like, it's gonna just crank out the answer. Should. There's a much simpler approach you didn't take, but I'm not sure it'd be more elegant. Well, keep that to yourself for now, but interesting. I feel like there's an interesting mathematical solution to this. Like, the fact that we're shifting bits and XORing, I feel like we could come up with a better pattern for predicting things. Yeah, but no, I think you're right. I think we could just, like, if I really want to, I could just rewrite this whole thing in Rust. Like, literally have it do the evolutions in Rust, have it store the data in Rust, have it stored all in memory, because, was it 13 gigs of memory? I think my machine can handle 13 gigs of memory. What do I have? That's 13 gigs written out to a file system, by the way. Storing it internally will be slightly different. Yeah, we're using 87 gigs out of my 128 gigs of RAM. I think we'll be fine on this machine. Yep. This is the brutest of brute force. Yo, it totally is. But I don't care, man. We're working over here. We got multiple solutions going. Yeah, graphing it could make it more obvious. True. We do need the whole series. That's also true. I think breaking it down to binary and just showing like how they translate from how the evolution happens in each 24-bit might be useful. All right, bonus points for anyone who can tell me what this is. Zelda. Metroid. Nailed it. It is NES Metroid Kraid's Lair. Zelda is a... something like that. What are some other Zelda ones? What was it? That's right. 30 years since I played Metroid. Well, you should play it. It's super fun. Yeah, I think I know that one. Hey! We have an answer. We have an answer. Winner is 0, 1, -1, 1 at 1710 bananas. Now, Bash is still 25% of the way there. So we successfully beat Bash, even with an extraordinarily slow solution. Let me ask you all a question. Do you want me to submit this answer? Or should I try and rewrite the rest of it in Rust using no cache, just reading the data as is? Because then I can actually get an idea of how fast this could go just in Rust. Submit and then rewrite? I don't know about that. I'm leaning towards not submit. Save the answer like I have answer.txt so I can submit it. And then come up with a clean Rust solution and see if I get the same answer. Because I'm more or less working against myself, not the real answer. Do the rest. What do you mean the rest? You don't know if you have the right answer. I know I don't know if I have the right answer. That's true. But I would change the Rust solution and see if I get the same answer. Because I could submit any of these answers. I'm not actually concerned if I have the right one or the wrong one or anything. What do we have here? What is my cache? We have the actions. Just close my... Okay, there we go. Let's make a poll. We could. Rewrite, then submit. Yeah, you know what? Here's what we're going to do. I'm not going to make a poll. This is not a democracy. This is my stream. I am not submitting. I'm writing that answer down. And we are going to rewrite it all in Rust while this Bash one continues to go in the background. And we're going to see if we can come up with 1710 as the answer. Final decision. I made it. Read and weep, losers. Okay. Let's grab the file as an argument. So file equals env nth. I think you can do this. Is that right? I don't know, let's just assume we can. Contents. We're going to read the file. We're going to take the file as an argument. Contents equals fs read to string the file. And now we are going to for line in contents dot trim dot lines. We may have to do dot editor on this. I don't remember. Print line return OK. Not found in env. What is it? Standard env. I thought it was nth. Or no, I have to collect them. There's like a function to collect them. We will not submit. You said no hints tactics for faster compute, right? Yes, please. No hints yet. here's what I think I can get the answer. I think this is going to give me the answer, and I don't care about the speed right now because I got the answer. Once I submit it and I'm happy with that and we're good, then I would love to hear what you guys think can improve this performance and, you know, better ways of approaching it. I am totally fine for that. But until then, please no solutions. What is it? What is standard N? Args. Yes, thank you. I couldn't come up with it. I was like, what am I missing? Yeah, args. Because I need the arguments. I'm thinking of environmental variables. Can you iterate over lines directly from a file? Maybe. You might be able to. Probably would make sense that you can without having to read the whole thing to a string and allocate space for it. Totally probably could. I'm not worried about like small optimizations like that at this time. Okay, so we have read a single number. So now that we have a number, what do we do with the number? The first thing we did was we cached all. So what do? We read the number and we evolved it 2,000 times, and we kept track of the price and the action. So we need an evolve function. Okay. What do we do? Source main. We're going to copy this over into Rust, and we're going to port it. So here we go. Evolve will take a number, so our secret, which is a U64, and we will take the iterations, which is a U size, and then we will evolve it. And we'll do a nice little for loop for blank in, how do you do this in Rust? Is it like 0 iterations? Yeah, and this counts up to iterations. Cool. So now we have this. Let's go ahead and keep the comments. The comments are good. Let's change them from £sign to a double slash. What did I do wrong here? Yeah, change the £sign to a... Okay, what's going on here? What am I doing wrong here? What is my trailing character? What am I doing wrong here? Oh, is it percent because of the selection? Yeah, don't use percent when you're using a selection. All right, click the result. Cool. Let result equal secret times 64. We need secret to be mutt because we're going to be changing it. Secret modulo equal results. Is that valid? I think so. Or secret XOR results. This. I think those are valid. Cool. Was it last? I don't remember what I named these variables. We'll figure it out. Okay. And then we just make a big string that we print at the end. Bonus activity idea, if you have time, would be cool to look at the machine code and see if Rust compiled down those multiplications to bit shifts. That would be kind of cool. I bet that it would. I absolutely bet that it would. Cool, Bash is still cranking away over there. Cool. Let's store the price and the action. We'll make a vector of results, and we'll return that as a tuple of price and action. So price will be a U64, and action will be an I64 because it's signed. And now we should keep track of these as a hash map of whatever we're going to call them, unrolled things. No, solutions. I need a better name for this. Oh yeah, okay. Action may be unset, so we will... What if we just throw them away? I don't care. Yes. What's up, man? Okay. So now we have the evolutions of all these. Yes. This is going to be a lot. Yep, so for the number 2, here's what all the evolutions look like. Okay, cool. We're getting there. There's a tiny optimization in the evolve code that sped up my C++ by a factor of 2 almost. If time the end would be fun to try it. Almost. Oh, cool. That's awesome. I know some of these words. Heck yeah, man. We're programming over here. All right, so we have all the evolutions now. Now, what was the next thing we did? We extract actions from them, right? So we have all of the... now we loop over and we construct every possible move and the price it costs to make that move. That's what we did. Okay. And once we're in here, we don't actually care what number it was. We don't actually need to store this. We just need to loop the results. Let me think about how to do this. We've looked at the thing. We've evolved it 2,000 times. We have the solutions. Now we need to loop the solutions for result in results. Might have to use a vec DQ. It'd be cool in the edited video for the stream. We got a graphic or something saying how long each thing took since you'd be able to measure them. I will definitely do that. I like to do that when I do the edited content because I can just go look at the timestamps and see how long it took. Like this bash solution is not even close to being done. But this, we're making good progress here. Yeah, we want a DQ, a vec DQ. We've used this before. This is a vec that lets us push to the front and pop to the front and push to the back and pop to the back. Won't the fact that you are not IO bound with this implementation already speed it up significantly? Yeah, 100%. This Rust solution should be like super duper fast once it's done. Like it should be ridiculously fast. Now that we've evolved the number that many times, we know the price and the action, so we can say, we can do a let else statement. Let action equal result dot one. Sum. No, wait. How do you do the let else? Is it like this? Let sum action equal result dot one. Else continue. This will just skip the first one, and now action will be defined here if we're there. Yeah, I think that's how you do it. So we can say let mut last equal, no, we've already stored the action, yeah. So now that we have that, we can just push the moves, the actions. All right. We'll push it to the front. No. We'll push it to the back. The action. And then we'll check if actions.len is greater than 4. Then we need to pop one. Actions.pop front. If actions.len is equal to 4, then we need to do something. The title, Advent of Code in Bash. Hey, you're just tuning in though. You're missing the important part, where the bash solution is done and it's running, because it's very, very slow. So what I do at this part of my stream is I race it. I let the bash solution continue to run while I go over to a different terminal, and then I write it in Rust and see if I can race it. So that's what's happening here. Let's see. What Super Nintendo game is this? It's got to be so hard to type this fast with a D-pad. Skill issue, get good. And this is it's a game called Advent of Code 2024. It's part of the Super Metroid Randomizer series. So right now, if I can figure out what to do when we have the length equal to 4, I will actually unlock the Various suit. And in the randomizer, that just gets you the ability to like withstand heat and stuff like that. It doesn't have the properties of the gravity suit. It's how the vanilla game works. The gravity suit would give you the properties of the Various suit. You don't get that, but yeah, it's just something to keep in mind. If it's equal to 4, what do? We look at how I wrote it before, so we can shut our brain off. Then we cache the price at that. Okay. So we can do it all in one step. If it's equal to 4, then we have a good set of moves. So we could find a way to store that gracefully as a key. I think you can just store a feck as a key. I think you can. How big would that get? Should I find a way of doing it? Whatever. We can do solutions.insert actions.clone and the... Oh, yeah. There we go. Moves.get solutions.get actions on wrapper 0, clone it, increase it by the price. I think that's it. A lot of things aren't going to work. Wait, I thought this was Super Metroid Link to the Past crossover randomizer? Yeah, I even got into the part where we have to jump into the Dark World. Welcome to the Metroid randomizer. Oh, what's the other one? Something like that. What are we doing here? Oh yeah, let else does need a semicolon. That's good. Not found in Vec. Cool. That's because that should be a Vec DQ. We're not using this apparently anymore. Cannot be formatted with default formatter. Okay. Okay, cargo run. Cargo build dash release. Let's get an idea for this. Cargo run -q dash release. Put a time in front of it, and then we'll give it the example part 2. Okay, I found this winner at 30 bananas. I don't think that's correct, right? Yeah, because the winner should have been 23 bananas with a... make sure I'm giving it the right solution. Yeah, we're giving it the right one. So that winner is incorrect. But man, did it get that incorrect answer really fast, huh, guys? Hey, look. We're almost halfway there in the bash solution. That's pretty awesome. All right, so what are we doing wrong? Let's see. Let's print out all the solutions we found. This might be my favorite puzzle I've managed to catch you doing so far. Yeah, man, we're in the monkey market. So, the monkey that stole the device seems willing to trade it, but only in exchange for an absurd number of bananas. The nice thing is the way that they choose to offer during this monkey auction is predictable, so I can predict what they're going to offer after 2,000 times. So once I just calculate out their price action, I can just, you know, rip them off. So that's my goal. All right, so the winner was at 30 bananas. Yeah, okay, so we definitely found a winner at 30 bananas. Oh, I know what. I know what we're not doing. We are, when we calculate the right moves, we're not ignoring future moves. We have to stop once we've processed one in the sequence. So for these results, once we see an action we've seen before, let mutt seen equals hash set new. Yep. Once we've seen this, so what we'll do is we'll check. Okay, once we have 4 here, if scene dot contains actions, then we do nothing. What do we do? Continue? Yeah. Otherwise, now we do scene dot insert actions dot clone. Yo, what's up, Elfaz? How you doing? All right, that's the correct answer. -2, 1, -1, 3, and it gives you 23 bananas. That's the correct answer. We did it. I'm gonna go ahead and delete some of this debug notation. That's the right answer. It takes that much time. Let's go ahead and run it with the real input. Okay, it took 1.7 seconds to do it, and we got 0, 1, -1, 1 at 1710 bananas. If we look at the cache values, 1710 is the correct answer. We know 1710 is going to be our answer. However, this bash solution is still going. We're about halfway there. And it feels crazy to not let that go, right? Now, this has been running for over an hour, probably. I don't know. People with YouTube could probably scroll back and see. I don't plan on letting this run on stream to the end, but I will let it run to the end just regardless, so I can at least capture, like, what the output was and if we got the correct answer, because I don't want to, like, leave y'all hanging here, you know? It would be nice to know if we can get the right answer. Do me a favor, please. What's up, Andre? What are you thinking? Well, that's significantly faster, huh? Imagine if we just did all these puzzles in Rust. How about rewrite bash solutions to the Rust approach? We totally could do that. Store it all in memory, because the file system is what's slowing it down. Replace the modulo with equals. Oh, okay. Yeah. That might be a way to do it. Also, the bash solution not using the cache, because the cache actually might just be slowing us down because of the file system nature of it. It might just make sense to use it. I am using some advanced data structures. I don't know how easy it'd be to parse it over. I mean, it probably would. It probably would be okay. But yeah, let's try that. So we're at 1.7 for the real input when we run it in release mode. So you want me to go to the evolution, and instead of doing the modulo equal, you want me to just and it with 1 shifted over 24 minus 1. Yeah, that'll work. Shifted 24 minus 1. That should be it. Let's do a cargo build release so we don't have to have any like timing slowing us down. Oh, it's just yelling about the extra parentheses. Russ is not a big extra parenthesis fan. What? Okay, what? $1.69. 1.729. 1.681. I mean, it seems like it might be 100 milliseconds faster, if even. It seems like it's, yeah. To get something useful here, whenever I do benchmarks, I like the benchmarks to take at least like 5 seconds, because then we're going to be bumping against like, you know, system timers and stuff like that. So we could just have normal system fluctuation. Also, my system is under IO load right now. Yeah, no problem. Actually, it's not at the heaviest IO load, because Rust did way faster IO load. It's just bash and a lot of processing. This bash solution is going to take a while, but it should give us the right answer when it's done. But yeah, I think that's it. That is the answer we wanted. Let me look at bash's part 2. Super well done. Yo, thank you. Appreciate it. Yeah, I'm wondering if it makes sense to rewrite the bash solution to not have cached to the file system. Because if I just did that from the beginning, you know, like rewrote bash to do what the Rust solution is doing, where we just return the price and the action, and then we just loop over each number, evolve it, loop over each one of those results, and push them onto some sort of like data structure. Okay. 30 minutes. I'm going to dedicate 30 minutes to this, and then I'm going to call the stream, and we're going to be done for the night, okay? 30 minutes. I am going to, while this bash solution is still running, we're going to backport these Rust fixes into a new bash solution. CP part 2 to part 2 new. That's what we're going to do. How does that sound, everyone? And then we will, of course, test the answer to make sure they all work. Because imagine if my answers were just wrong. As far as I know, I should not edit bash script while it's running. Is it true? Yes, I wouldn't do that. So that's why I CP'd part 2 to part 2 new, so I can edit a completely different script. I wouldn't want to do that. Yo, Andre, thank you for the $5 super chat, dude. I think it's super cool. You super chat every time I get a solution done. Well done, Bash and Rust in one stream. Great fun as always watching you get here. Yo, appreciate it, man. That's super nice. I haven't submitted it yet, so we haven't got the points for it yet. But let's go ahead and let's do this. Bash reading script line by line on the go. Yeah, it may or may not be read into memory. So this is going to be one of those things that, like, it really depends on your operating system. Like, truly it does. So here's what we should do. We should pull in... I'm going to pull in everything. So, evolve part 2. Oh, I can't edit these. Yeah. Okay, I can't edit evolve part 2 without part 2 possibly breaking. So, I'm just going to pull everything into one script. So we'll grab the entire evolve function as is and bring it into our script. So now with this one, we have our end, we have our secret. What we will print here is we will print the price and the action, and that's it. Rash now. Yeah, that's what we're writing. We're writing in Rash now. It's a brand new language. Yeah, also, anyone who's still tuned in and you like what you see, you like Rust, you like Bash, you like problem solving, you like programming, if you're watching on Twitch, go ahead and hit that follow button. It's super cool when you guys hit it. We were at 262, so we've gone up six followers since I last asked. And if you're watching on YouTube, go ahead and hit that subscribe button. It's super fun when you do it. And everyone likes you and thinks you're really cute when you do it. So go ahead and hit that button, all right? Love you. You don't need full cache, by the way. You can do this in a rolling fashion, so you don't need the full cache in Bash. A rolling fashion. I'd have to think about that. I know what you mean. No, I don't know what you mean. But that's fine. We're just going to do this. All right. So what do we do here? So we loop over the file, we evolve it. Let's just grab this. So now I'm doing the opposite, where I'm going to port Rust into Bash. While read -r line do done number. That'll read it from standard in. We can do while read -r price action do done, and this will read in from evolve num 2000 times. Okay. Now we have to do that crazy logic to extract the cache. You're doing the 2000 steps per buyer first, and then you go back and get the 4 value action window. You can just track the 4 value action window while you're doing the 2000 iterations right there. I see what you're saying. Yeah. Gotcha. That's a good point. Only getting looser with the tips since its performance you've already solved 3 times. Yeah, totally fine. At this point, guys, I consider it basically solved. So if you guys have other ways of approaching this, let me know. Otherwise, I'm just going to keep doing what I'm doing here. Oh, we're at 24,000. How nice. Yeah, no, you're totally fine. In my mind, it's already solved. I know I haven't submitted it yet. I don't actually know what I'm waiting for. But we're going to just do this. Key is the buffer separated by spaces. If -n solutions key, then continue fee, otherwise cache it. Solutions key, no cache it, plus equal the price to it. We also need to keep track of a scene. If -n scene, then continue, otherwise scene key equals 1. If this is not, no, we don't want to continue. We just, we want to do this no matter what. Yeah. Okay. Still don't know yet if it's right. Let's see. Yeah, I'm excited to see what Bash can do with this algorithm as well. Oh my god. That's so much faster. -2, 1, -1, 3. We'll get you 23 bananas. That's correct. That's it. That's so much faster. It's... Am I crazy? Is this faster than the Rust solution? No, this is the example. This is the example input. This is the example input. Okay. All right, that feels better. I mean, it feels better that it's not 1.7 select. Yeah, 1.7 seconds. Yeah, okay. It was faster than the Rust doing the full input. Okay, this is taking longer. I'm okay with this taking longer. That is totally fine that this is taking longer. Yeah, I would guess like 45 seconds. I didn't time it. Let's time it. It'll just be fun to know. And let's go over here. This one's still chugging away. Oh, that's so funny. Yeah. Yeah, I guess it'd be 45 seconds, but now I'm thinking it's going to take longer. How's everyone doing tonight? You all well? That brute force isn't always the solution. We learned that caching to the file system isn't always the solution. I think brute force worked just fine. This is basically equivalent to my solution, which after some optimization ran in about 1:20 seconds. It started out at 1:46, though our inputs are different, which may affect the runtime. That is very true. Did you tell me what language you did your solution in? I don't remember if you did or not. Did you mention... I don't remember if you said what language you did yours in. But yeah, I'd be interested to see about that. Greetings from Mexico, Dave. Yo, what's up? What's up? How you doing, man? Welcome. Greetings from the US. We learned that on day 17. That's very true. Oh, it was the Bash version. Oh, okay, cool. Hey! Hey, look at that. 1:56. Okay, so similar to what you were saying. 1:46. Yeah. 0, 0. We'll get you 1710. 1710. And we keep getting 1710. So Rust has told us 1710 from our cache. Rust has told us 1710 with no cache. Bash has told us 1710 with no cache. Bash has told us nothing with a cache. I'm at the point where I actually don't even care about this anymore. I know it'd be fun to let this thing go, but like, we got it with a Bash solution. So I am content with that. You guys ready? Moment of truth. I'll wait a second so people can catch up. But yeah, we're about to hit the moment of truth. We keep writing the same algorithm, keep getting the same output. Weird. Oh, man. That's so weird, dude. Computer science is so strange. Are we all ready? We're going to do it. 3, 2, 1. Let's go. Let's go. Nailed it. That's the right answer. You are 1 gold star closer to finding the chief historian. Let's go. You have completed day 22. 3 more days left. I didn't know if I would get past like the first 5 puzzles in this. We got past 22 of them. How awesome is that, dude? We are crushing it. We are absolutely crushing it. This is awesome. 3 left. I won't spoil them. I have no idea. People said 25 was awesome. People said 25 was epic, and that's what I'm excited for. And I haven't heard anything bad about 23 or 24. Not asking for spoilers. I don't want spoilers. But I didn't hear anything about 23 and 24. I just heard 25 was epic. So I'm excited for that. Woo! Yeah, GG indeed. GG indeed. Solved it 4 times? Hey, no, I solved it 3 times with the 4th solution possibly going to work and on its way. I think this one will work because I implemented this verbatim in Rust, so unless I have a syntax error, it's going to work. God, I gotta just let this run, right? There's no reason to stop it. I could just let it run. Oh, an extra bonus for the super cool bash rewrite. Dude, that's what I do it for, man. People ask, why do you write code? And honestly, it's for... I write code for Andre in the YouTube chat, who super chats when I complete these puzzles. I write it for Andre super chat. That's why I code. Thank you, man, dude. Much appreciated. That's so funny. Oh, man. Yeah, dude. Andre with the super chat. It's so sick. I said I wasn't going to stick around till this finishes, but like, dude, I feel like we almost have to. You don't have to. NNBB, go do your thing, man. Have a good night. Take care. Thank you for stopping by. I appreciate it. Yeah, if you made it this long, I'm not even going to ask you to subscribe. I would like if you did, but if you made it this long, I'm going to assume you're already subscribed and you just appreciate the vibes. So awesome, man. Thank you for hanging out. Dude, I feel like we got to let this finish, right? Like, we're so close. No matter what happens, I'm going to end stream once this finishes, but we gotta just let it finish. I think there's no way around it. I'll let this go. I'm going to go grab a drink. I'll be right back. I'm back, gamers. We were at 39.2 out of 49. Oh my God, we're going to get there. We are absolutely going to get there. Yeah, it should be less than 5 minutes. That's what I'm thinking. Ooh, that's sick. Oh man. I'm so glad this is happening. Honestly, this is really cool that we're going to get there. What's going to happen? My money's on it just prints the right answer and we're done. It just prints 1710. 1710. It worked. It worked. It printed it. I was right to put my money on it. It worked. Wow. I didn't run it with time, so I don't know how long it took. We will have to look at this VOD on YouTube when I'm editing it to actually put like a progress meter and actually figure out how long it took, but it worked. So we had the answer immediately. It just took 13 gigs of cache data to get there. 13 gigs of cache data. How stupid is that?